we're gonna discuss about the files here. So previously we discussed about the room database, right? Shared preferences and data store, and we also learned how the data was being stored and was written in files, right? So now the big question is, where are these files stored? Okay. These files are particularly stored in the internal storage. So internal storage is pretty much dedicated to the space for every application that other applications are unable to access unless if the device is rooted, right? So there is no limit to the amount of storage your app can use. However, users have to have the ability to delete the app's files from the settings menu. Internal storage occupies a smaller part of the total available space, which means that you should be careful when it coming to storing a large files, right? So don't store large files there, right? Like your videos or MP3s, like sound files, right? So there is also an external storage, right? So the files that your app stores in external storage are accessible to other application, and the files from the other apps are accessible to your ones too. So right. So there is a difference between internal storage and external storage. Internal storage, as I told you, has a less memory, so a very limited data will be stored there. But whereas for external storage, you can store any amount of large files there, right? So for internal storage, the files that we just discussed before, like the files created by room, the files created by shared preferences, the files created by the data store, are pretty much written in our internal storage, and they are pretty much you can just explore them using your device file explorer. Okay, but for that obviously you need to run your application. Okay, and let me explore my device file explorer, and it is pretty much the file is lies under your data, okay, and under your application package name. My application package name is com dot, this is my application package name, where you have your files, right? As I told you, all your files like that we previously created for data store was being stored here, like as you can see here, right? My new data, and this was my previous data store. It's my saved data in data store. You can also have your shared preferences files, right? Your preferences with the respective key and its values, right? So yeah, this is where you can explore your files, right? Okay, so now being said that, so let's go and focus in our internal storage. So internal storage provides multiple methods, like your context class provides multiple methods. All right, if you can explore, you can also go and explore your context class provided by your library, where which provides multiple methods to return the absolute part of your directory, right? So yeah, you have just your library provides multiple this method for which returns the root folder, which returns the given directory of your application files, the cache directory, or the directly with the provided name and the mode. Okay, so yeah, you can just explore them, and I would like to present you guys with two before important practice that we are going to use to read a file and also write a file. But let's create a read file passing the context. So here I'm going to read a cache file. Cache directory, context, cache directory, file to read from file, cache directory, and your file name, okay, size, file to read from, length to int, bytes, byte array, and you pass your size, temporary buffer, your byte array, and your size will be your temporary buffer, your file input stream will be your file to read from. And you now try to read your file. How you read our file? From your file input stream you read your bytes, passing the offset of 0 and the size. If read is less than size, you remain size read, while remaining is greater, still remaining, like we still remain to read, then we keep on reading the file with the temporary buffer. Otherwise the system array copy buffer by its size is minus remaining read. Yeah, this is how we read, but here we are not only reading, we are just okay, let me just do this. So we are reading a cache file as follows, right? So this is our cache files reading. And finally, obviously, after trying, we should catch if there is exception of IO exception, then we throw the exception, and finally we close the file right after reading. File input stream close. Now this is the simple order, simple way, whatever you can say, to read a file. And you can also write a file, obviously passing the context, because context has all those necessary methods as I already told you. And okay, so we are gonna write a file here, bytes to write byte array of 100 and cache directory, context cache directory, well, file to write in goes to cache directory, and your file name to write, of course, text. And now we try to write our file. If file to write in exists, then we file to write in create a new. If doesn't exist, you see, there is a negation. Then we create a new file and start writing. Otherwise we write the file out to stream, file to write in, put stream, write, bytes to write, file output stream, close, catch the exception, okay, dot print stack trace. when we catch the exception. Yeah, this is the simple procedure how to write a file, right? Simple, using simple method provided by file output stream, right? And we close the file. Okay, so like there are many alternative ways to dealing with the files, like the readers, like stream reader, stream writers, and so on. They are better equipped for character based data, so there are also third party libraries that help us with disk input output operations. Like one of the most common third party that helps with IO operations is called Okio. Okay, if you don't know, just let me go and just write it down here. Okio started its life as a part of the OK HTTP library, which is used for combination with the retrofit to make API calls. The methods provided by Okio are the same methods it uses to write and read data in HTTP communications. Okay, so we also have now the difference. This is the internal storage. We also have our external storage. And for our external storage, obviously reading and writing in our external storage requires user permissions for permissions. Okay, so if our write permission is granted, then your application has the ability to read and write the external storage, right? So there might be problem when user might not choose to grant these permissions. However, there are specialized method that offers you the possibility to write to the external storage in folder dedicated to your application. So some of the methods for external storage some of the methods for external storage are you have, obviously you need a context. You had you have your file. You can get your context, get external files directory. Yeah, you can get your external files directory with the okay string type. So here what we have is like modes like string type. It's nullable, so you can pass your type to null, but your your external files. So you just need to pass a type here, right?
Sì, giusto per avere, come dicevi tu, una specie di tabella di mapping per dire in questo componente serve
Okay,
questo,
here.
sì, chiaro.
Environment directory, music or podcast, movies. Okay, yeah, we get the values from here. Actually, you can see here. Okay,
Sì.
let's import the values. Yeah, so you can pass your all your types here, like movie or and so on.
No, no, questa qua è quella vecchia,
And you also have now get external cache directory, get external cache directory. Okay. uh, yeah, this is all about the external storage, guys. And just note that avoid using hard-coded paths for files and folders, right? The Android operating system might shift the location of folders around depending on your device or Android version. Okay, so this was the simple differentiation about internal and external storage. And thank you.